everyone, welcome back to GDC classes. So in this series, as I've told you before, Target Pharma 360, we are going to cover all the important topics with their relevant MCQs also. So it is highly obvious that you are also required to pay much attention to these topics as well as to the concepts we are going to teach you in these videos. So without wasting any time, let's start with our MCQs. But I also need your feedbacks and recommendations in the chat box below. How much you have scored, what exactly other topics you want us to frame for you all. That feedback helps us to improve as well as guides us to the path which is required by the students, because this series is specifically designed for our students which are motivated enough to polish their concepts. Okay, so let's move forward to our first question. Okay, so the topic will be rheology. The first question says dilated flow is characterized as the reversible phenomena of what? Right? Dilated flow, if you remember, in the non-Newtonian systems, right? We have Newtonian systems, we have non-Newtonian systems, in which we have time independent systems, we have time dependent systems. Okay, in the time independent systems, we have plastic systems, we have pseudoplastic systems, we have dilatant systems. Okay, plastic, pseudoplastic and dilatant systems. In the time dependent systems, we have thixotropy, we have rheopexy, and anti-thixotropy or negative thixo and negative rheopexy. So these are the phenomena, right? So they are asking about the dilated systems. Number one, pseudoplastic systems are known as shear thinning systems. Shear thinning systems. And dilated systems are known as shear thickening systems. Why? Because dilated systems are known to expand, dilate, increase in the volume. So we say dilated systems are shear thickening systems, while the pseudoplastic systems are shear thinning system. That means the viscosity will reduce, okay, in the shear thinning system. In the dilatant systems, the viscosity will increase. So in this case, we have dilatant system. So the correct answer must be pseudoplastic systems, where with the slightest of the shear that is applied, the material is able to flow very easily. So we say these are shear thinning system. So I think it is clear. Dilatant systems are shear thickening, pseudoplastic are shear thinning. Plastic systems are generally referred to as Bingham bodies. Okay, clear? Next, second question. Kinematic viscosity is the ratio of dynamic viscosity upon what? So most of this time the question is asked. So it is based on the simple phenomena. Kinematic viscosity is the ratio of the dynamic viscosity upon density. Note it down, very important. Kinematic viscosity is equal to dynamic viscosity upon density. So I think now you know we have our correct answer as option number A, density of the fluid. Okay, correct answer is option number A. Next, anti-thixotropic behavior is shown by what? Again, very important phenomena, but let's see what exactly is this anti-thixotropic behavior. Now, I think you must remember, I have just told you non-Newtonian systems. Non-Newtonian system, I think I have written it reversely. It is non-Newtonian systems which were categorized as time independent, which we have seen plastic, pseudoplastic and dilated. Other ones were time dependent systems. Okay, time dependent systems involve, I'll give you one example of gel to sol to gel conversion. Gel to sol to gel conversion. Suppose initially in the gel state the viscosity is higher. So once you apply the shear stress, this stress causes the viscosity to reduce because now the gel state is converted to sol state. Gel state is converted to sol state, so the viscosity is reduced. Now you remove the stress. Now you remove the stress and let it rest. Now you remove the stress and let it rest. Every word I say is important for this MCQ series you need to attempt. Listen to me carefully. Gel state is a higher viscosity state. You apply the stress, it converts to the sol state, viscosity reduces. Then you have to remove the stress and keep it for a while at resting period. So it comes back to original state. Here we say it is known as thixotropy, where it comes back to its original state upon removing the stress and keeping it for a while at a resting period. So we have thixotropy. Okay. Now if this gel to gel conversion was happening, but you do not allow it to rest. You do not allow it to rest, but you make the process faster by applying any additional turbulence, by applying any additional your vibration. Now this process of conversion again back to gel state will be known as 𝘎𝙎𝘾𝙎𝑐. So one difference is there. Gel sol gel conversion upon removal of stress and at a rest period it converts back to its original state. But once if you apply any additional step without giving it rest, just removal and give any additional vibration, gentle agitation, then the conversion becomes little faster and then we have our 𝘎𝙎𝘾𝙎𝑐. Okay, so this is how you differentiate between thixotropy and 𝘎𝙎𝘾𝙎𝑐. Now there is one more example of sol to gel to sol conversion. Just reverse of it. Sol, gel, sol conversion. Similar here, you apply the shear stress. Initially, the viscosity was less. Now, the viscosity will increase. Okay. Now, the gel will be converted to sol again. That means the viscosity will again decrease. Okay. So, this happens after removal of stress. Now, you remove the stress and let it rest. This phenomena of conversion from sol gel back to sol with the application of with the removal of stress and let it keep resting state, this is known as negative thixotropy or anti-thixotropy. So I hope you all know what is anti-thixotropic behavior, where the conversion from sol to sol take place. But when you remove the stress and let it rest for a while, this is termed as negative thixotropy. Similarly, if you want it to convert quickly and you want to make the process little faster, you remove the stress. You remove the stress and apply any simple shaking, gentle agitation, vibration, turbulence. Now it will be termed as negative or anti-𝘎𝙎𝘾𝙎𝑐. I think I have been able to explain you all over the four phenomena, which is very important. Okay, so it's thixotropy is gel, sol gel, isothermal and rebuilding of structure back to original state. But additional, you have to keep it for a while. It is a slow conversion. If you want this conversion to be literally fast, you have to apply some gentle agitation, vibration, turbulence. Then it is termed as 𝘎𝙎𝘾𝙎𝑐. Similarly, the states are reversed. You take sol gel sol as an example. You have negative thixotropy and negative 𝘎𝙎𝘾𝙎𝑐. So coming back to the question, it says what is the behavior, anti-thixotropic behavior shown by which? So please note down, magnesium magma actually shows this anti-thixotropic behavior. Magnesium magma. Okay. Next question. In which type of the fluorogram curve passes from the origin? Now when we are talking about the Newtonian and non-Newtonian systems, you all must remember it is a relationship between what? Rate of shear and shear stress. Rate of shear and shear stress. So basically the direct relationship is shown by the Newtonian systems only. So otherwise in the non-Newtonian system we have the non-linear relationship. So I think it is much easier to say that the 𝘎𝑔 will be linear and much more passing through the curve in the case of the Newtonian systems. where the rate of shear and shear stress are directly proportional. Okay, option B is correct. Next, flocculated suspension show which type of flow? If you remember non-Newtonian systems, and in which we have talked about the time independent systems, we have plastic Bingham bodies, we have pseudoplastic, we have dilated. So I have already told you plastic systems are Bingham bodies, pseudoplastics are shear thinning and dilatants are shear thickening system. So generally the dilated systems dilate or expand in the volume. Most important example here is of the deflocculated suspension. In the pseudoplastic systems, we generally have gums and mucilages as the example of the pseudoplastic system. For the plastic systems, we have flocculated suspensions. These are all the important examples I have listed. So I'll again back to the question. Flocculated suspension, this is shown by the plastic system. I am clearing every concept with a detailed explanation. I hope even if somebody doesn't know the answer, they must learn it right now. Next, Haeckel's plot is used to measure. See, we have already seen the plastic, pseudoplastic, dilatant, Newtonian, non-Newtonian system. Have I ever mentioned of any plot which is Haeckel's plot? Direct relationship between rate of shear and shear stress. So please eliminate the correct options, eliminate the non-correct options which we have studied right now. So we'll be left with our compaction properties. Okay, fine. Next question. Deflocculated suspensions have type of flow. See, initial investment always comes in mind later. So deflocculated suspension, for D, for dilated, dilate, expand in the volume, we have dilated systems as our correct answer. For the flocculated ones, we have plastic systems. Okay, just before this we have covered it. So option C is the correct answer. Next, which of the following is exhibited by Tragogan solution in water? See, gums, mucilages, pseudoplastic, shear thinning system. Flocculated ones, plastic systems. Right, deflocculated ones, dilatant systems. I hope it is clear. So, Tragogan, gums, mucilages, these mucilages are formed. This is shown by shear thinning systems, which are pseudoplastic systems. Okay, option D here is correct. Next, the cup and bob viscometer, type of cup and bob viscometer in which stationary cup and rotating bob. So option A cuvette type, option B Searle type, both or falling sphere. Please note down, cup and bob viscometer has two possibility. Number one is the cuvette type. In the cuvette we have C first. So here the cup will rotate and bob will be stationary. The cup will rotate and bob will be stationary. Second one we have our Searle type. Here the cup is stationary and bob will rotate. Okay, now is it clear? Now I think it is easy to answer for you all. So in this case, cup and bob viscometer, cup is stationary and bob is rotating. That is our Searle type cup and bob viscometer, which is of basically involving cup is rotatory or bob is rotatory. Okay, in this I think the answer is incorrect, but we have our correct answer Searle type. Not C option, we have B option as our correct answer. Note down. Okay, next, Oswald viscometer is a type of for which of the following fluid? So generally for the viscometers we classify, for the viscometers we classify them as for the single point viscometer, for the multi-point viscometer. These single point viscometers are used for the Newtonian systems, multi-point for non-Newtonian and Newtonian systems also. So basically majorly for the Newtonian systems we have single point viscometers. In this single point viscometer we have falling sphere viscometer and the type will be Hoppler viscometer, and we have Oswald viscometer. as a type of capillary viscometer. Okay, and for the multi-point we have CCB, cup and bob, cone and plate, and Brookfield. Now I think it is easy to remember. Okay, so directly they may ask you about the non-Newtonian system, which viscometer is used, cup and bob, cone and plate, and Brookfield viscometer. For the single point Newtonian system, we have falling sphere or Hoppler, Oswald or capillary. So they were asking about the Oswald viscometer, which is a type of what? Single point Newtonian systems. That is how you answer the questions, and these are most expected important topics. Okay, so option A is correct. Okay, moving on. Transformation of sol to gel at resting state. That means I will break it for you. Sol to gel but at resting state. If you remember, this rest state was a second phase. That means it must be gel to sol conversion. Then the stress was removed and it was kept to rest, and then it was converted. So they have just given you the statement of this. So what is this gel sol gel conversion? This is thixotropy behavior. Okay, so correct answer must be thixotropy. Otherwise, they should have given you more details, but for that, this part we will have our resting state included in the second half. It will be thixotropic systems. Okay, option D here is correct. I think in this document it is wrong, but option D must be the right answer. Okay, next, SI unit of viscosity. SI unit of viscosity is nothing but poise. Usually we have multiple other units as well, right? Then one SI unit is, I think, Pascal second also, that is also mentioned. So other units are centipoise as well. For the options that are given, I think poise is the correct answer. However, this is not the actual SI unit. This is the standard unit we use. We have Pascal second also. These are included into other units. Okay, so we have poise. Right. Next, the type of viscosity specified in IP, Oswald viscometer. We have already seen the dynamic viscosity, the kinematic viscosity, which is differences of just divided by the density. So it includes both dynamic and kinetic viscosity. Okay, kinematic viscosity. Next, the change in the velocity between two planes of liquid, which is separated by a distance, is called as what? Now, this is very important. See, just to explain you a bit, suppose you have a liquid. So these are the layers of liquids which are well represented by the planes. These are the layers of liquids which are well represented by the planes. Now you apply the force. Now you apply the force or shear stress you have applied. This will result that this will shift. Let's suppose the bottom one layer is fixed. Okay, rest other, because the force is applied on the upper end, it will shift. Okay, this shifting will be done and this distance moved is dx at a velocity dv. So this force is proportional to this velocity gradient. More better we say this force by area is proportional to the velocity gradient. Where is the velocity gradient? This shift because of the shear stress, right? So we say the shear stress is directly proportional to rate of shear. Okay, how you have obtained it? In response to distance. So we have dv upon dx, that is the shift with the velocity what and to what distance. So the distance between two planes when it is separated by a certain distance and change in velocity, this will be referred to as none other than our rate of shear. We have seen right now F by is directly proportional to dv upon dx. So that velocity gradient is nothing but our rate of shear. Next, Mach-Michael viscometer belongs to which of the following type of viscometer? We just have seen our cup and bob viscometer, right? We just have seen our cup and bob viscometer. The option was incorrect. So cup and bob viscometer includes cup rotates, bob stationary, bob rotates, cup stationary. right? So in the first QA type, main example is the 𝘂𝐾𝙀𝙎𝑃𝑔 viscometer. So I hope it is now clearly understood. It is not cone and plate, not capillary, not falling sphere viscometer. It is our cup and bob viscometer, in which the QA type example is the 𝘂𝐾𝙀𝙎 viscometer. Okay, so we have option D as our correct answer. Okay, next, the flowability of a substance can be described by thixotropy. So, increases the viscosity, increases the fluidity, decreases the viscosity, or sedimentation. Thixotropy is what? Gel, sol, gel conversion at rest. Initially, the viscosity was higher and the stress results in decrease in the viscosity. So, the flowability of a substance in the thixotropy, it results in decrease in the viscosity. In the question, if it is mentioned to you about the condition of rest, then you will say increase in the viscosity after the question says rest period has been given. But the thixotropy phenomena is explained by the gel sol phenomena. So it says the viscosity will reduce. Okay. Next, creep testing is used to analyze the viscoelastic properties. Because we are talking about the rheological systems, we are talking about the viscosity behaviors there, right? So viscous and elastic behavior, these are shown by viscoelastic materials. So this is generally explained by the semi-solids. So I think now it is explainable that creep testing is for those viscoelastic models. So we have semi-solids there, right? So the correct answer looks like ointments are included which have paste-like consistency. Okay, so we have ointments as our correct answer for the creep testing. Okay, next, which of the following is a single point viscometer? Just before this we have covered single point for the Newtonian, multi-point for the Newtonian, Newtonian both. So single point majorly includes falling sphere, Oswald, capillary, Hoppler. Okay, falling sphere example Hoppler, Oswald is an example of capillary viscometer. So now you got the answer as the falling sphere viscometer in the cup and bob type. Okay, plug flow is a disadvantage of. See, you have seen multi-point viscometer. What were the different multi-point viscometers? CCB, cup and bob, cone and plate, and Brookfield. These were multi-point viscometer. The cup and the bob, let's suppose, was somewhat like this. Cup and bob, let's suppose, was somewhat like this. So when it rotates, what happens? Here the material keeps on sticking. Here the material keeps on sticking, which gives the issue in the measurement of the viscosity. So what happened? We have changed the design to more of cone, right? So we have a cone shaped material. This results in the plug flow. This cup and bob system looks like it results in the plug flow, due to which the material actually attaches to the bob and it restricts its movement, and we have a very different readings which were supposed to give the false results, right? So we have cone and plate viscometer, in which the design allows no plug flow restrictions. Okay, so we have plug flow in the cup and bob but not in the cone and plate. So plug flow is a disadvantage of cup and bob viscometer, because the material keep on sticking here, which restricts its flowability. Okay. Okay, option B here is correct. Next, non-Newtonian systems show which type of behavior? Right before the start, we have seen the graph of Newtonian and non-Newtonian systems. Newtonian systems usually show linear, and non-Newtonians, thus they are much non-linear. Okay, so we have option B as our correct answer. Okay, so that's it for today. This is all about the rheology. Important topics we have covered, and I hope you all have got the right answers and enjoyed the explanation as much as I have enjoyed delivering the explanation to you all. In the chat box below, please note down what scores you have obtained from this series, and any other suggestions are most welcome. Thank you so much. We will meet in the next video.